So as I mentioned in the previous video, if you're trying to work part C, the only part that you change from working part B is N. So that's going to change your standard deviation. N changes from 13 to 26 in this problem. So once we calculate everything again, if 100 independent samples of n equals 26 students were chosen, the probability of that happening is 0.0207, and so out of 100, we would expect 2 to have a sample mean reading rate of more than 95 words per minute. Part D, what effect does increasing the sample size have on the probability? Increasing the sample size decreases the probability because sigma sub x bar decreases as n increases. For part E, what it's asking for is a conclusion for what this teacher has found to be true for her new reading program at school. After 10 weeks in the program, it was found that a mean reading speed of a random sample of 19 second grade students was 93.9 words per minute. So we need to use a sample mean where x is greater than 93.9. So we change that to a z using the sample mean 91 and the sample standard deviation 10 over the square root of 19, which gives us a z-score of 1.26408. When we do normal CDF to be the area under the curve bigger than that value, we get 0.1031. So this is not unusual because we would expect a reading rate of 93.9 or higher from a population whose mean reading rate is 91 in 10 of every 100 random samples of size 19 students. So you would choose option B and fill in the information accordingly. Part F says there is a 5% chance that the mean reading speed of a random sample of 22 second grade students will exceed what value? So we don't know x bar this time. We have a random sample of 22 second grade students, so n is 22, and we know that there's a 5% chance that their reading speed will exceed this value. So we set it up this way. The probability of x bar being bigger than an unknown value is 0.05. If I have a 5% chance of being bigger than this value, then in decimal form, that is 0.05 because we divide the percentage by 100. So because we want to be greater than 0.05, that is this tiny little area over here in the z-curve. But when we are given the area, we have to use inverse normal. And when we use inverse normal only gives us the amount to the left of the indicated value. So since this is 0.05, the area here is 0.05, I need to do an inverse normal on 1 minus 0.05 to know what indicated value this is because it gives the area to the left. So that's why I have taken inverse normal of 0.95. That gives you a z of 1.644854. So to get that out of your calculator, what you do is you do second VARS, take you to DISTR, distribution. Inverse normal is choice number 3. So we're going to hit enter after we've highlighted 3 and 0.95. Enter gives you that z-score of 1.64485. So to get an x, when you have a z, you use this formula. So I've got z in place of z. Sigma is 10 divided by the square root of 22 because we have a sample size of 22 students plus 91. We're asked to round to 2 decimal places. When you type that into your calculator, you get 94.51, which is what I've typed in as the answer.